Okay, so for those of you who are one of my students, this is not on your quiz review because this is what we did in class on Tuesday where we did that re-practice for our performance assessment. But this is for those of you who just want an extra practice problem, or for the other teachers, students, you do have this as your number 4. So my students, this is a good practice for your performance assessment. Other teachers, this is your number 4. All right, so it says this is our polynomial function, and it says the sketch a graph of the polynomial. So the way that you should start is that we need to find all the zeros. So that means each term needs to be set equal to 0. So 2x plus 1 needs to be set equal to 0 and solve. When you do that, you pretend like you're back in algebra 1 and you're solving, you're dividing this by 2, so you get x equals -1/2. So that means that -1/2, you're going to put one of your zeros. Then you're going to take the next linear term, x plus 2, and you're going to solve that for 0. This one is the one that we should just know by now, which is -2. So I'm going to put a 0 for that. And then this one, I'm going to solve this one, x minus 2 equals 0. So that will give me x equals +2. So that will be my 0. This is squared. That doesn't mean that I need to do like a second point or another point above it or anything. That's just going to come when we sketch the graph. That's going to come back because it says a multiplicity of 2. This -3 does not impact it because there's no way that we can make -3 equals 0. So that's not a 0. If it was -3x equals 0, then yes, we can make x equals 0, and that would make it equal 0. So because it's -3, it's not a 0. If there was an x there, we would need a answer from it, which would just be 0 in that case. So now that we have all that, it's asking us to sketch a graph of the polynomial. So we need to know which way it starts and ends. So this is where we need our end behavior. Now for my students, we learned that we can just multiply all these numbers together to find the leading coefficient and the degree, which is what we need to do the starting and ending behavior. So we do -3 times 2x times x times x, and then there's another x here because this is technically x minus 2 squared. So it's really x minus 2. So -3 times 2x times x times x times x. -3 times 2 is -6. And then there are 1, 2, 3, 4 x's. So it's -6x to the 4th. When I have that, I know that my leading coefficient is -6 and my degree is 4. So when we look about starting and ending behavior, I know this is what we use in my class, is that we decide if our leading coefficient is positive or negative. This is supposed to be negative. If it's positive, it's going to end positively. So it's going to end going up. If the leading coefficient is negative, it's going to end negative. Then we can determine how it starts by the degree. If the degree is odd, it's going to end opposite, kind of like if you like rotated the D's around, odd and opposite look a lot alike. So that means if it's ending positive, it must have started negative. And if it's ending negative, it must have started positive because they have to be opposite of each other because it's odd. If it's an even number, then it needs to start the same way. So if it's ending positive, it needs to also start positive. If it's ending negative, it needs to also start negative. So this would be a negative positive. This would be a positive negative, positive negative. This would be a positive positive. And this would be a negative negative. So now that we know that, going back to what we got -6 as our leading coefficient and 4 as our degree. So -6 is our leading coefficient is negative. So we're looking in this spot, and then our degree was even because it was 4. So it's a negative negative. So that's telling me that when I graph it, it's going to end going negative and it's going to start going negative. Start going negative over here and end going negative here. So now I'm just going to loop this down. So I just go through and kind of make like a roller coaster and connect all of these, except when I do that, it's going positive. And I am supposed to have it going negative. This is where that multiplicity comes back in. So where I said up here, where that square doesn't really affect the zeros, it affects the graph. So because this is squared, it's not going to go straight through +2. instead of going straight through +2 like I drew it, it's going to bounce off of it. So it's gonna come up, it's gonna touch 2, and then it's gonna go back down, and now it's going negative, negative. So if you don't do that multiplicity of 2 for this one, you're gonna get wrong ending behaviors, which should tell you that you're doing something wrong. All right, so it says that's one is sketch all the graphs. Now it says name all the horizontal and vertical intercepts. That just means tell me the x-intercepts and the y-intercept. The x-intercepts we already said are these numbers, -1/2, -2, and 2. So these would be x equals -1/2, -2, and 2. For my class on your performance assessment, this is where it says solution roots and zeros. And then the vertical is where it crosses here. So we can see here where it crosses. We should look at the constant up here. So to find the constant, we're going to multiply -3 times 1 times 2, and then times -2 squared. So this is going to be negative. Oh, wait, sorry. I said -3. This is not, yeah. -3 times 1 times 2 times -2, and then it's squared. So times -2 again. So -3 times 1 is -3, -3 times 2 is -6, -6 times -2 is +12, +12, and -2 is -24. So this would be -24. So then we can adjust our graph so that way it goes, this part goes down to -24. And then for my students, this is why we just set our scale once we have the constant. All right, and then state the end behavior, we already said it was negative, negative. All right, and then my class, if this was a performance assessment, you would also have to then write this in standard form, which is what I did in question number 1. It was a little bit different of a problem, but it would still be the same thing. But for everybody else's classes, you don't have to do that part.